Hello and welcome. Thanks for watching. This will be the first of two videos on coding in Python, which is part of a 6 video series. First two videos were about what is programming and how does computers work in general, and this will be specifically how to code in Python for these next two videos. This will be the first of those two. So you may wonder, why Python? Why choose that language? There's a ton of programming languages out there. Well, it's on the rise as far as usage goes. It's probably the fastest growing language, and it is absorbing more and more of the tasks that computer programmers take on in real world applications. So Python is growing hugely in the computer programming world. And it's also very user friendly. It's close to natural language, so it has a real similarity to the way we speak. And so the code just kind of makes sense to a new person. That's a huge advantage. Also, it has a great online community. So python.org is an example of a website that has a Python forum. There's also one called, let me see if I can type this in. So reddit.com/r/Python is also a great website for Python assistance. So there are a ton of people that are not just willing to help you, but eager to help you with any programming challenge on these websites. So easy to use, easy to find a job in if you're a computer programmer, and also um, great community with people eager to help. So all those are reasons why Python is a great choice to learn to code. So let's talk about a website called Repl.it. A lot of trouble that I have in teaching computer programming has to do with getting a bunch of different computers to run the same programs and have the same result. So some of the kids in my class might have an iBook, some might have a PC laptop, and you got all these different operating systems, and it's a challenge to get it all to work. Well, one great solution is this website because they run all sorts of programming languages. You can type the code straight into the browser. Their server will parse it for you and spit out the result, and there's no differences across computers. So go to this website, repl.it, hit sign up, and I recommend you use your Google account or your Facebook account just because it's quick and easy and you'll never forget it. But if you feel like you want to, go ahead and create a username, email, and password. Something you'll remember. If you're a teacher, you should check this I'm a teacher box. They give you a few additional features. Um, so yeah, sign up with that. Pause the video and create an account and go to the Repl.it uh, home page, and then come back and I'll show you what to do next. Okay, so I'm assuming you've got that done. So your page should look like this. And so I think they ask you some first time user questions down here. You can ignore all that if you like and just hit new Repl.it, I believe, and you're going to choose Python and create Repl.it. Now, if you're using a different browser, it might look ever so slightly different than mine. Feel free to pause the video here and play around with it until you can figure out how to make a new Repl.it in Python. And this should say Python 3.8.2 or greater. So that number or larger is what it should say. All right, we're going to change the name. So I clicked on this up here, and this is the default name. It gives it just a nonsense name, Adored Scientific Natural Language. It's just something, it pulled from a pool of words and created a random name. Instead, we're going to name it Coding in Python Part 1. So we can see that uh, and we will know exactly what it is. So if I use the hashtag symbol in Python that comments out the line, that tells the computer to ignore what comes after this. So it's just a note to myself. So coding in Python part 1 like that, and that'll be just a note to ourselves that this is that. Um, file. So the first thing we're going to talk about is simple data types. So simple data types, make a note here. Really, basically, the more comments you do, the better, as I have said earlier. So the first of those simple data types we're going to talk about is an integer. So an integer is a number without a fractional part, and let's make that note here. So it's a whole number, no decimal, no fractional part, just a number without any part of a number. So we're going to call this integer, and I'll call it integer 1 equals 5. And integer, and I'm naming these variables in ways that'll help us remember what they are. So I have integer 1 equal to 5, integer 2 equal to 10. So variable names, be careful with variable names. There's a few rules. Well, there's a ton of rules, but a few that are going to cause you errors more often than others. You can't start with a number, and you can't use a reserved name. Now with repl.it, it's pretty neat because if you use a reserved name, do you see how that changed colors? That tells me that's a reserved name. So if I try that, or see how those change colors? If they change color, that's a reserved name. If it doesn't, like so, then that's okay. And you also can't start with a number, so don't do that. So here I've followed the variable naming rules, and you also can't have white space. So I can't name it like that. That would not work. So no white space. That's why I use underscores here to simulate space when we can't use one. So no white space in your name. Can't start with a number. Don't use reserved words. And that's true for all types of variables. Okay, so these are both integers. Let me show you how to print them out to the console. It's with the print command, and that's going to make them pop up over here. So first, let me show you what this would look like without these. So notice nothing happening over here because we declared these variables to be equal to something, but we didn't print them out or do anything with them. And so nothing comes on the output. But if I do this, well, now it's going to show me what both of them are. And also I can check their type, what type of data they are with the type command. So let me do that. Actually, I need to type it like this. So that tells me in both cases they are integers. So we've got 5 and it's an integer, 10 and it's an integer. And we can do mathematics with these. So there's a lot of operations with integers. And they work exactly the way you would expect. So we'll do the sum. And you see, as you would expect, that's 15. We can do the difference. Be a minus sign here. That'd be -5, as you would expect, because 5 minus 10 is -5. We can do the product. In other words, multiply them together. That's the asterisk symbol. And 5 times 10 is 50. And we can do the quotient. And that's with the division symbol here. So notice that it changed to a decimal because 5 divided by 10 is not a whole number. So this by default can switch to a float. So it can switch to a float, which we're going to talk about next. That's a number with a fractional part. Okay, so let's do that. Floats. So that's the second type of, and I'll type 1 here and type 2 here. So the second type of simple data is a float. That's a number that may have a fractional part. So let's make float number 1 and set it equal to 5.0. We'll make float number 2, or underscore 2, I should say, and we'll set that equal to 8.9919. Just picking random numbers there. And let's do the same thing where we print those out. So let's print float 1, and we'll print the type of float 1. So we're calling this type function on the variable, and it's going to print out and tell us what type it is. You remember before it was an integer this time. If we did it right, it should be a float. I can copy paste for a quick shortcut there. Another thing about computer programming, any typo, any little symbol in the wrong place will make your code throw an error. So if that ever happens in the midst of this video, if you're following along coding with me, you get an error, just pause it, go back and compare your code to mine, and you'll see where the little differences are. Or it might take a while. Sometimes it's a really tedious task to find a period in the wrong place, for example, or something like that. But take your time, you'll find it, and then resume the video. That'd be the best way if that happens to you. All right, so that's floats. Next, and also let's talk about operations with floats because they are the same. So operations, let me make sure that's a comment. So we have also the sum, the difference, and now there are more mathematical operations. I'm just using the 4 most common. Yeah, I'm just using the most common here. So you've got things like exponents and roots and absolute values and all sorts of other stuff, but we'll tackle those as we need them in coding challenges. So notice the sum, difference, product, quotient all work just the way you'd expect them to. There's none of the weirdness with integer division. Remember, it turned it into a float. Well, it's already a float here, so that's not a big deal. Okay, so the next type of variable, and here we get into a little bit more challenging concept, is a string. So this is just a list of characters. Yeah, with no mathematical value. So just a list of characters, no value. So I'm going to say string 1 equals, and we have to use either single or double quotes to declare it as a string. So it doesn't matter what I name it. I named it string 1, but if I said this is 5, well then it's an integer. So your entity over here has to be encased in parentheses, single, or I'm sorry, not parentheses, but quotation marks, single or double quotes. And whichever one you start it with, you also have to end it with. Repl.it automatically throws that second one in there. Repl.it also does what's called IntelliCode or something like that, where it recommends things as you type, which I hate. And you can turn it off if you click on this settings, and go down to code intelligence and then do disabled. So I do it that way because I hate that recommending stuff for me. If you hate it like me, feel free to do that. All right, so let's make this string hello world, and we'll do, and this one will be 1, 2, 3, 4, 5. So let's print that string, and let's also print the type of that string, just to make sure we've got the right type. And then we'll do the same thing for string 2. Okay, so hello world, and then 1, 2, 3, 4, 5 string. Now notice with the number, this really looks like a number, but it's not. It's a string. It has no mathematical value. If I tried to add 5 to it here, Python's going to hate that and throw an error because you can't mix up integers and strings, because this is a string. It's, even though it's 1, 2, 3, 4, 5, looks like a number, it's not. It's a string. So strings can deceive you in that way if you're not careful. Okay, so next will be the last. That was type 3. This is type 4, which is called a Boolean, B-O-O-L-E-A-N. And this is pretty simple. This is either true or false. And Python likes for you to capitalize the T in true and the F in false. So a Boolean is either a true or false statement, and it's a logical test, a conditional often. Okay, so the way we do this is I'm going to say bool underscore 1 equals true, and bool underscore 2 equals false. Now notice when I type the first part of that, it changed colors. That's telling me I can't use bool as a variable. But if I do an underscore and then a number, then it's fine. All right, so let's print out those. And let's print their type too, just to make sure that we've got the type that we want. And this should be 2. Okay, so you know what an integer is, a float, a string, and a Boolean, I hope now. So those are different simple data types in Python. And sometimes we want to switch from one type to another. And this is something we're going to do very often. And there's a little bit of weirdness involved, so let's take some simple examples first. So let's imagine we want to go from integer to float. So that's going to look like this. If I have an integer, so x equals 5, and I want to change that into a float, I can say x equals float x, and this changes to a float. So let's print x and then print the type of x. And I'm going to go ahead and comment out that previous bit so that that doesn't keep popping up. Okay. So 5.0, notice it went from 5 to 5.0. It just tacked that 0.0 on the end. That's how it became a float. Now it has a fractional part, even though that fractional part's 0. Hopefully that makes sense. Okay, let's see. Yes, that's pretty much all there is. Integers to floats will always just add a 0.0 at the end. What if I want to go integer to string? So x equals 5 and x equals string x. This changes to string. And so we'll do the same thing here. So here we see it looks the same, but it's a string now. So this one is tricky. Now if I want to go float to integer, this one is kind of weird. Because what it does is it just always rounds towards 0. That's kind of funny, but it rounds towards 0. It just takes whatever fractional part's on there and it throws it away and gets closer to 0. And even if it's like 3.99, if I change from a float to an integer, it becomes 3. Let me show you what I mean by that. So we'll say x equals 3.99999. So that's a float, and I want to change it to an integer. So this changes to int. Now you would think it would round to 4. Nope. It rounds always towards 0, no matter what. And sometimes repl.it takes a second to run. It's no big deal. It's the servers get clogged sometimes. So notice it rounded down to 3, even though it was 3.99. Man, so it takes any fractional part, throws it away, goes towards 0. What if I had a negative number? That can be confusing. Negative 2.97. And we'll say y equals integer y. And notice I'm using the same variable over and over. It just rewrites it. So it starts from the top down. So the earlier line numbers are parsed first, and then the subsequent ones supersede the earlier ones. So whatever comes last is the one that counts, if that makes sense to you guys. All right, so notice that negative 2.97 goes to negative 2. Remember, always towards 0 with Python. Strange. Um, not mathematically typical, but it's useful for a lot of reasons that we'll get to later. But something to be conscious of. This is why a lot of trial and error is involved in coding. Float to string, no big deal. So this works exactly like you would expect. So we'll say x equals 3.99999 like earlier, and we'll say x equals string x. So this is going to change it into a string. And then we'll do this again. And notice it is 3.99, which looks like a number, but it's actually a string. Valueless list of characters. So that's float to a string. Now, what about strings to integers and strings to floats? So it has to be an integer type string. It has to be something that could be turned into an integer. So if I say x equals, and I'm going to name this one, or set this one to be 5623. So it looks like a number, but it's not. Notice the quotes. That is a string. So we're going to turn that into an integer. All right, now we'll do this. And notice it has become an integer. However, if I were to do this, and let's say I throw an A in there, watch what happens now. It fails because this one is not an integer type string. And if I go from string to a float, it's the exact same rule set there. Let's see. Okay. So we'll say x equals 5623.56. And then this time we'll change it into a float. And then we can run that, and we see that it is now a float. So switching back and forth between data types, very important skill set. Um, so at this point, you should know what the 4 basic data types are in Python. You should know how to go back and forth from one to another in the ways that are possible. You can't turn a Boolean into anything else, basically, or anything else into a Boolean. So Boolean doesn't play nice with the other types, but here we see how to convert between the 3 types that do play well together, at least sometimes. Okay, so first task for you guys. I would like for you to create a string named myString that's equal to hello world. Create an integer named myAge that is equal to your age in years. Create a float named myDecimal and set it to as many digits of pi that you remember. Create a Boolean named myBool and set it equal to true. All right, so pause the video here, complete those tasks, and then come back when you're ready. Okay, so welcome back. Here we go. First of all, create a string named myString that is equal to hello world. My underscore string equals hello world. So there's that task. Second part is create an integer named my underscore age that's equal to your age in years. So there's mine. Create a float named my underscore decimal that's equal to as many digits as pi as you can remember. I think that's right. Let me double check that. 3.141592. Yeah, that's all I remember. You'd think a math major would know more of those, but I don't. That's it. Okay, so Boolean named myBool and set it equal to true. Okay, so that's what that first task should look like. Hopefully you were able to figure all those out. All right, next, let's talk about outputs. So there are a couple ways we can output to the console. You've already seen me do several print statements. That's the primary way. So I can print either, let's say I have a few variables here. So I've set a few variables here. Let's say I want to print them out one at a time. I'm going to do that with individual statements like this. That prints them one at a time. You'll see that after I run it here. If I wanted to print them all on the same line, I can use one print command and separate them with commas like so. So that prints them all on one line. Okay, so already time for the next task. Let's see here. So take the variables you made in task 1 and print them all out on separate lines. And take all the variables you created for task 1 and print them out on the same line. So pause the video, do that, and then come back and we'll see how you did. All right, welcome back. Here we go. Let's look at task 2 here. All right, so print out all the variables you created for task 1 on separate lines. So we want to print, and we've got the first one is myString. And then we've got print myAge. And then we've got print myDecimal. And then we've got print myBool. So let's make sure that works. Yep, that printed them out on 4 different lines. Now I want to print them on the same line. So I'm going to print, my underscore string, comma, my underscore age, comma, my underscore decimal, and then comma, my underscore bool. And here we see that prints it all out on one line. So task 2 accomplished. All right, next let's talk about inputs. So input is when we get data from the person using our program. So I'm going to take all the stuff we've done so far and comment that out so it doesn't interfere with what comes next. And now if I parse it, you'll see nothing happens over here once it finally runs. Taking its time here, that's okay. Input. So inputs work like this. I can use the input function, and I normally want to declare, yeah, there we go, nothing over there. I normally want to declare a variable. So I'm going to call this input underscore one equals, and then the input function, and inside the function as an argument, I'm going to put a string that will be our prompt to the user. So I'm going to say what. Okay, so we're talking about inputs here, and again, the prompt we're considering is, what is your name? Let's imagine we want the name of our user. So that's going to prompt in the console, and I'll show you what that looks like. What is your name? Now notice again we have the cursor right next to that text. One way to fix that is if we put a \n at the end of our prompt. You'll notice now it's down here. I just like that better. So if I hit enter over here, it's going to record that name as input one. So let's create a print command that's going to give that. All right. Put in a random name here, and you'll see what it does. Probably a bit more grammatically correct if we had a comma there. So this is an example of getting an input from the user. Now it is by default a string. So what if I wanted a number from my user? So let's say what is your height in inches? And we want to, let's say we want to print out what that height would be in meters, just picking something random there. Let's look up inches to meters. So we'd need to multiply by this value. So that's our conversion. I'll just put that in there as a comment. But we've got a problem. So if I were to do it like this, zero, 2, 5, 4. It's going to throw me an error here for a couple reasons. Well, we got to get to that part first, I guess. So you see the error occurred because you can't multiply an integer and a string, or a float and a string, because this is not an integer. Remember that even if they put in a number, and I'll do this too while I'm thinking about it, make it go down to that next line like we did before. So even though this they enter a number, it records it as a string. Remember, strings can look a lot like an integer or a float, and that's the case here. So in order to change the type, you'll remember we use this technique. So that's going to change it into an integer. Then we still got a problem because we can't add together an integer or a float and a string with this plus sign. So we could do it with commas and it would work. But another way is I could change that into a string, and then the plus sign would work. we do need a space here to make our formatting nicer. I think this will be a good final form for this. So that's how we get data from a user and we manipulate it using console inputs. Beware again that the default type is always a string. Okay, so I got a little task for you guys. If you want to pause the video and then create code that asks the user for their name and store it to a variable named username, print out a personalized greeting to your user using their name, ask your user for their age and store it to a variable named user age, then change its type to an integer, and then print out how old they will be in the year 2050 using a math expression. So that's your challenge. See if you can do those 4 things. Again, pause the video and then hit play when you're done. All right, see you guys in a second. All right, welcome back. Let's do these tasks and make sure you guys got them right. So first task was to ask your user for their name and store it to a variable named username. So you do that like this. Username equals input. And then the prompt is, what is your name? And again, I like this at the end because it takes it down to that next line. Just a formatting thing. Print out a personalized greeting to the user using their name. So a couple different ways to do this. So if you didn't do it exactly like me, that's okay. It's already a string, so we don't have to worry about that. Let's do this because that wouldn't require another reply. All right, and just make sure that works. Yeah, works good. Okay, so next task is ask your user for their age and store it to a variable named user age, then change its type to an integer. So user age equals input, and then what is your age in years? And then we want to change it to an integer. Can't leave it as a string. All right, so print out how old the user will be in the year 2050 using a simple math expression. So what we're going to do is how old they are now, and then in 2050 will be in 30 years. So we're just going to add 30 to it. So we're going to print out and remember that we need to either use commas or change it to a string. So I'm going to change it to a string. So we'll say user age plus, and we'll do 29 because it's 2021. So string user age plus 29. If you're like me and you got an early birthday, you know, it could be a little weird, but we'll just assume that at some point in that year, they would be that age, which would be accurate. Okay, so let's see what happened there. And 44. So I'll be 73 in 2050. Man, be an old dude. Okay, so anyway, that's how you would complete that task. Moving on, let's talk about complex data structures. So complex data structures hold more than one value. So all the variables we've talked about so far hold one thing. They hold one thing only. Whatever you set them equal to. A string is sort of a complex data type because each character is its own thing, but we kind of treat it like a simple data type in the way we've used it so far. Integers hold only that number, floats hold only that number, booleans hold only a true or a false. So that's one thing. Complex data structures are different. They can hold numerous elements or multiple parameters, et cetera. And the first complex data type we're going to talk about is a list. So in Python, a list is indicated with, and we'll set this equal to these brackets. So this is what tells Python you're going to have a list. You're working with a list. So a list can hold a lot of things, which is important to computer programmers. Sometimes you want a collection of data together in sort of a folder, if you will, and that's the function the list can serve. So let's imagine I wanted to make a list of 4 things, and I'm going to use all 4 different data types. Uh, so there's a list with 4 elements in it, and I'm going to print that list out for you guys. And you'll see that, and we'll go ahead and comment out this stuff because there we go. We don't want that messing us up. So you'll see it prints out that collection of 4 items that I initially saved the list to hold. So the brackets, this symbol is what indicates to Python you're talking about a list. And if you use other delineators, like parentheses or braces, it's not going to work the same. So make sure you're using only brackets for a list. Now, lists have an index for each element. And the plural of index is indices. So indices for the elements in the list start at 0, and that's real tricky. I don't know if you guys ever watch British comedies or movies, or you've been maybe to Great Britain, but they do something a little weird with the floors in their buildings. So the ground floor is just that, the ground floor, or the 0th floor, if you will. And then the next floor up, which we would call the second floor, they call the first floor. And then the next floor up, they call the second floor, we call the third floor. So it's easy to get confused because, and it's that confusion arises as a consequence of indexing differently. So with lists, it also has a confusing index, just like the British people do with floors on a building. It's the 0th index is the first one, and then the first index is the second element. The second index is the third element, and then the third index is the fourth element. Let me show you how do you call the index by um, using the list's name, and then in brackets afterwards, you select an index value. So that tells them it to print out the 0th element of the list. So you see it just gives me that 1. What if I wanted the second element? Well, then I have to put a 1 in here. So you see how the indexing can be confusing? So that's the second element, even though I put the first index, because it starts at 0, and that's super confusing. Let's say I wanted the fourth element. I need to put a 3 in here. And we'll do a couple more examples here. Uh-oh. All right, so hopefully that makes sense to you guys. The index of a list starts at 0, and it can be pretty confusing. So here we can print them all out like so. Some functions we can do with a list, some things. Let's say, I've already got a list created, and I want to know the length of that list. That would work like this. So the length is the function, and inside as an argument is the list's name, in this case list 1. And you notice at the end it tells me it has 4 elements. And the length is straightforward. It doesn't start at 0 when it counts the length. It just counts how many elements are in it, 1, 2, 3, 4. And then it spits that value out, 4, you see right there. So that's calling for the length of a function, which quite often we want to run a loop, the exact number of times that there are elements in a list. So that's a function we use quite often. Say I want to add something to the list. A couple ways I can add it. So the first way is with append. So if I want to append an item to the end of a list, you can do it this way. So let's say I want to say list number one, and then dot append. And let's say I want to add hello to the end. And then I'll print the list again. I'll comment out this stuff. So now you'll see it has that new element at the end. But let's say, hey, wait a minute, I didn't really like that. I want to remove it. So the way remove works is like this: the variable's name, then dot remove, and then the thing I want to remove. Like so. So now notice in the second case here, that extra element that I added is now gone because I removed it. So you can add and remove to a list on the fly using these two functions. There's also a way to stick a value in at a certain point, which we'll talk about later. But for now, this should suffice. Append and remove. Sorting. So let's imagine we have a list we want to sort alphabetically. So let's make a new list. And let's say we got band names here. Uh, this one's kind of hard to spell because they spell it weird. I think that's right though. Pick another weird one here. And then, if you could tell, I'm a 80s dude. Okay, so let's imagine we want to sort this alphabetically, which I almost did by accident, but not quite. So we're going to print list 2 as it is. And once again, I'll comment out the old stuff. So there's our list, and I want to sort that alphabetically. So what I can do is call the list and call the sort function. And then if I print list 2 again, notice it switched Genesis and Motley Crue again. I almost said it alphabetical by sheer chance, but those two needed to be switched. And so when we sort them, that happens. That's the sort method. It sorts it alphabetically. And if you have numerical values, so this is about sorting, and this part was about adding and removing elements. Try to make sure to comment this out well. I'm going to share this as a link, this file, main.py that I'm creating, as a link at the bottom of the YouTube video. So if you have trouble keeping up with me typing, which I can't imagine that that would be the case, but if it is, you'll have that file there. Okay, so sorting numerically, let's do that. List 3 equals 2, 3, 7, 0, 11, 1, 5. Okay, so we'll print list 3. We'll just use the same code we already created and change all these to list 3. And notice that when I sort a numerical list, it just puts it in ascending order, as you would expect. If I sort a list of strings, then it sorts them alphabetically. So let's say we want to make a pretty big list of numbers. We would usually do that with a for loop, which I haven't talked about yet. So when we get to the for loops, I'm going to show you guys how to make a list a big list of numbers with a few simple lines of code. Okay, quick task for you guys. If you would, create a list called My Faves and include your 5 favorite things as strings, then print the list. Remove an item from My Faves, add an item to My Faves, and print out the modified version of My Faves. So you guys pause the video and do those 4 things, and then come back and I'll show you whether you got. All right, welcome. So here we are again, and I task you guys with creating that list. So we'll just say my underscore faves equals, and then we use the brackets, remember, because this is a list. And I'm going to put a taco, burrito, got food on the brain, pizza, steak, and I don't know, hot dog. So we'll imagine this is a list of your favorite things, and we want to remove an item. Let's say hot dogs doesn't exactly make the cut. So I've decided to remove it. Or you can use single or double quotes, it doesn't matter. Add an item. So instead of remove, we'll append. And what do I want to add to my list? Let's add a healthy option, salad. And then print out my underscore faves. So let's see how that goes. Yep, and then notice it has salad here because, steak. Oh, that's cut off by this thing. Okay, so that's not actually missing. It's just interfered with by this icon here. All right. So now let's talk about loops. So in programming, a lot of times we want to use what's called a definite loop. That's a loop that runs a certain number of times. We know in advance how many times we want to run it. So we're talking about the next big thing, for loops. So for loops are going to run a certain number of times that we always know in advance. There's another thing called an indefinite loop that we'll get to later that runs an uncertain number of times. But anyway, so let's talk about the for loops, definite loops. So the way that works is for, and then I'm going to put a variable here. So I'm going to say I in range 100. That's going to make it run 100 times. And we're going to print out that variable I 100 times. So if I did that right, it's going to do 1 through 100 here. Well, actually, it starts at 0. So if I wanted to do 1 to 100, I have to do +1 there. There we go. Well, I guess we got to clear that because it's not going back to the top. There we go. So 1 to 100. All right. So there's a way we can use that same technique to create a list of numbers and even a list of modified numbers. Okay, so let's say I want a list of numbers from 1 to 100. So I'm going to make a variable. I'll call it number list, and I'll make it an empty list for now. And then I'm going to say for, and I'll comment this out. In range 100. So that starts at 0 and goes to 99. So we want to add 1 to that if we want to start at 1 in our list. So we'll say num underscore list dot append in +1, and then print num list. All right, so this really, let's see what we got wrong here. Oh, forgot my parentheses. Still, Python 2 was one of the first languages I learned really well, and so in Python 2 that would have been okay. Often make that mistake. So here's our list, numbers from 1 to 100, and We'll clear out that old stuff so it's not confusing us. But here's the numbers from 1 to 100. That's our list we created. What if I wanted like a unusual set of numbers, like every um, third number? Well, I could do that like this. Okay, take that too. And bad white space equals failed code in Python. So the way I pasted that and it was tabbed out, that would have broken my code, or at the very least done something weird. All right, so let's do 3n plus 1. So 3n plus 1, that's going to give us 0 times 3, which is 0 plus 1, so that's 1. And then when we hit 1, that's going to be 3 plus 1, which is 4, and then so on. So it's going to start at 1 and then go up by 3 each time. Oh, I have to put a times symbol in there. And then my insert is off for some reason. Okay. So no, notice now it's 1, 4, 7, 10, 13, going up by 3 each time. And I could do a lot of interesting things with that. I could do I could add every squared number here. So if I do n times n, actually I would want to do n plus 1 times n plus 1. So that's going to give me a list of squared numbers, 1, 4, 9, 16, and so on. So I can make this expression whatever, and it will populate my list with this many entries of that particular mathematical expression. All right, so looping through a regular list, let's go back to my list of bands. Let's imagine I want to loop through this list. Let's say I want to sort it alphabetically and then loop through it and print everything one at a time. All right, so first of all, sort it. And then let's say I want to do for band in list underscore 2. And this doesn't have to be band. It could be X, anything. It's just the variable you're using. I use something that describes what the elements are. That's considered best coding practice, to use variables that refer to what the elements tend to be. It just makes your life easier later on when you're debugging it, trying to figure out what controls what. We just want to print that band. Now, once again, this could be X, but I'd have to make this X too. So whatever this is, this has to be. So this is the variable that we're iterating with, and this is a call of that variable. So it's going to sort it and then print them out one line at a time. So it's going to go through this loop over and over again until it runs out of elements in that list. All right, and let's say we want to ask our user a series of questions. We can also do that with the for loop. So for I in range 5. So we want this to run 5 times. Notice I'm using the colon after the for statement, so that is required. It will not function without that. And notice I'm tabbed over underneath it. That lets the system know that this is what I want to run inside that for loop. So for I in range 5, let's say I want to know x equals input need this here. What is your, and then remember that I is a number, so we'll change it to a string. I plus 1, because we start at 0. There we go. So what is your number? And then 1 and 2 and 3 and 4 and 5. Favorite food. And let's make a list beforehand. Empty list. And now we're going to add that whatever they put into that list. And then after the loop is over, so notice I'm going back to the leftmost justification. That tells the computer did not run this during the for loop. We'll print out the foods list. Okay, so let me comment this out, run this. What is your number one favorite food? Let's say it's steak. What's your number two favorite food? Burger. Number three favorite food? Taco. Number four favorite food? Chicken wings. What's your number five favorite food? Pizza. And then it prints all that out. So, all right, I think we're ready for the last task in this section. Next to last task, okay. Nope, last task, okay. So this is going to be using the list you made in task 4, my faves. Print out each element on individual lines using a for loop. Create a for loop that creates a list from 1 to 100. Create a for loop that creates a list of even numbers from 2 to 100. Create a for loop that runs 5 times and asks your user for their 5 favorite movies and then prints those out. All right, so pause the video, complete these tasks, and then come back. Okay, so our last little task for today, use the list you made in task 4, my faves, and then print out each element on individual lines using a for loop. So for food in my faves, don't forget your semicolon, print food. So that's going to accomplish task 1. Sometimes these next ones will take a little trial and error, but we can figure them out. For I in range 100, there we go. And we'll make an empty list first. Okay, so we need to tab over under our for command, and we'll say num list2 dot append I plus 1, because we want to start at 1, not 0. And now let's print our list to make sure we got that part right. All right, let's see. Oh, don't mistype your variable or it won't work, as you see there. So that looks good. All right, now we want to create one that does a for loop for even numbers. I'm going to use this code as a base here, and we'll change everything to 3s. So actually we only need to go to 50 here, and we want to take I plus 1 and multiply it by 2. That's one way to do it. There's more than one way to do it, so if you did it differently, don't worry, as long as it worked. 2, 4, 6, 8, and so on, up to 100, so that works. Finally, create a for loop that runs 5 times, and I'm going to use some of the code I had earlier here. Just change it around. So we'll say, instead of foods, we'll call this one movies. And generally don't uppercase the first letter in a variable. No specific reason, it's just not conventionally done. What is your number one favorite movie? We'll ask them this time. And then we'll print it out nicely to the console. For movie in movies, print. We'll just do it like this. All right. Okay, so let's see. Looks good to me. What is your number one favorite movie? We'll just say Predator. Uh-oh. Okay, yeah, I forgot to change that to movies. Remember, if you change a variable in one spot, you got to change it everywhere. Predator. First Blood. Rocky 4. Spaceballs. And Star Wars. And it says a favorite movie of yours is Predator, First Blood, Rocky 4, Spaceballs, Star Wars. So thanks for watching, you guys. I hope you enjoyed it, and I'll see you next time.